So this is week 4 portion of the lecture of current topics in finance, and this time I think I'm going to go through homework number 1. Um, you must have had a hard time doing all those problems yourself, right? And together with your teammates, right? Um, by the way, if you are still looking for some teammates, right, open up to the general public in the notice board or the iCampus thing, right? So please let everybody else know that you are looking for teammates, right? Um, so if you are having difficulties, there must be a lot of you, right? You are not alone. You are not alone, right? Um, we are struggling together. So let's go. How things work out, okay? Um, and the answers that I try to give you over here, I bet you this is not the best answer because I am new to the R coding anyway, and I realize this is crazy. I mean, when if you were given in SAS, I would be like doing in like 30 minutes or something, but R, new language, takes forever to do it. I know. Um, um, but we're going together. And another thing is, don't, you know, just get hung up onto this R only, by the way. What I'm saying is, coding is coding, right? We go together. But what is also important is your interpretation of the results, right? Of the results. Um, don't just throw out numbers or graphs and stay deaf, right? Here's my result. Don't you understand? No. Um, what's your story? Okay, what do you find? Anything interesting, right? Tell it. We gotta be different from the mosquitoes. We gotta be different from those engineering guys, the poor, unfortunate souls, right? So we have to be the ones who can tell some stories out of it. Okay. So let's go one by one. All right. Um, what was the first question? Yeah, I have to shrink myself down. Yeah. All right. Homework 1. Using pickups CSV data, generate these colored scatter plots. Okay. Oh, before I forget, I need to tell you this. Try to have make it your habit. Okay, make it your habit to keep a data note, data journal. Okay, data journal. I say it over here. Data journal. SKKU, CTF, Andy Kim, right? And then this data journal, what is this for? Well, memory is a scarce resource, right? I bet you 10 years down the road, okay? 10 years down the road, you may have to come back to your data that you worked today. Okay? Oh my God, Andy, there's no 10 years from now. I'm gonna be like, no, no. At your age of 20 or something, I thought there would be no 40 years old in my age, right? There will be like only 20 years old forever. No. As it turns out, you get aged and then your work, okay? Hopefully, you'll live with the data, okay? This is the generation of data science, and it's not gonna go anywhere, okay? It's not going to go, which means you will have to live with your data, and then you'll have to familiarize yourself with living with the data. And one thing is, you need to set up your habit, okay? Make it your habit not to forget what you did in your data, okay? I started that kind of habit at the age of 30 or something, and it worked nicely, okay? You're even younger than me, so you can do it, and then it will be helping you. So that's why I tell you, you have to keep data journal with you. Data journal here, to make sure the note is something not ring binder based, but something that you cannot just rip off easily. Okay, this kind of data note, this kind of not a data note, this kind of note ring binder, bad. No. Why is it bad? Because you can rip off and forget about what you did. Okay, um, but this kind of note is way better so that you can keep it in your bookshelf, and 10 years or 5 years later you can always pull it out and then see what the heck was in your mind when you were merging certain data, right? Data A, data B, what was the merger? What was the idea? Why did I, merge these two data sets? And then what was the merger keys and all these things, right? You want to keep track of those things over here. Okay, so that's why I just wrote down some sample um, data map, right? Data map like this. Each data shown in a box like this, and then moving down to a new data set, right? I label it and then say what it is, and then it splits into two data sets, and then other things like that, right? So you have to be able to trace what the heck is going on, and then if there was an error, you need to debug those errors, and data map will help you in that respect tremendously. Tremendously. I tell you right now, if you are sick and tired of doing it, then there's always a choice not to do data science, right? But as long as you want to do data science, you need to make it your habit to keep your data journal somehow, okay? So that you will not forget that, right? So keep it, make it your habit. Right. So that's one thing. Maybe I should show you at some point a sample of my data journal that I still keep, but let's wait for that part. Anyway, question number 1, using pickups CSV data generate these colored scatter plots. Yes, Dodge, Ford, and GMC, right? That was rather easier part, right? So why don't I start anew, right? Remove all those work that I was doing. Oh my God, what if I cannot come back? But what the heck? I'm gonna erase all of those and start a new man. Okay, good. So, yeah, I'm gonna be here. Like this. Good. Now, if you look at this, right, homework number 1, remove the list, right, and then let's just to see where I am at. Okay. Yeah. So my work directory is C data R, so I'm happy about it. No need to change it or anything, right? Let's play with pickup truck data. And this guy is in my work directory. Yeah, trucks. And then, yeah. And then here, the log of price I want to generate based on the truck's price vector, price variable. And then, yeah, so it's going to be in this trucks data set, okay, like this, L price. Add them to your data. Yes, I did it. And then picture, right. So color scatter plot, right? Color scatter plot by groups. You need to install a package called ggplot2. Okay, ggplot2. Yeah, install, right, like this. Oh yeah, I already installed this one, so I don't need to do it right now. But when you turn on your computer for the first time and then start this R program, make sure you install these things. Right now, for demonstration purpose, I already installed it, so I don't need to. Another thing is, once you install it, make sure you call that package up with library command like this. Okay, and then the next thing is this one, ggplot trucks AES and year like this. Okay, voila, voila. You see these are showing up in different colors, right? Depending on the makers, Dodge, Ford, GMC kind of, right? And then the yeah, geometric point, right? Geom point. It does not mean the jump point, right? Anyway, and then that's a chart scatter plot between year and price. Okay. The next thing is miles and price, right? The more mileage that you ran, the lower price your used car would be, right? So that makes sense over here. And then you saw that graphs, one graph at one time, right? One graph at a time. How about plotting those two graphs in one shot, right? Here is the command that you can use, right? Using install packages and grid extra, right? Call that package and then use ggplot and then use this grid.arrange. And there you set those one graph as A, the other graph as B, and then row and column number, one row, two columns, matrix of this graph. You can think about it this way. Okay, so the price of the pickups by the year and by miles, you can see some scatter plots like this. With this, you can see, you can have some good information right away. A picture is worth 1,000 words, right? Who's, prices, right, change more sensitively to the mileages, right? Different makers show different sensitivities, right? For example, over there in the right hand side, you see GMC, right? Comes from, right, 25,000 about, all the way down to like what's that? Less than $1,000 worth as we move down the road. And so it's widely scattered around, whereas Dodge, it is rather clustered over here, right, in the middle range. And then the Ford is something in between. Okay, you can see, you can distinguish those things using different ways, right? Yeah. If you want to increase the point size, you can do it over here, right? Anyway, some of you were trying to trying regression of price against the year by different car makers. So let's just do it for now and think about what's going on later. Okay, so it was suggested by 이일규, and that was good. So let's see, ggplot, and then you see a regression, okay, between, regressing price against year, right? Some explanatory power coming from the years, right? You can see that. Also, you can run some regressions like this, right? The inverse relation between price and mileages, right? You can see it. You can see that those slopes are somewhat different depending on the what's that? The makers, right? And then if you want to change the colors, right, you can do it this way. And then this is a regression line without distinguishing those makers at all. Okay, one regression line. So what am I trying to say here? If you think about those previous ones, right? Previous ones, two pictures before, right? Here, you are assuming different slopes, different sensitivities, depending on the makers, right? Whereas 2 slides down the road, you are assuming just uniform slopes, regardless of the makers. But the advantage of the former, right? Different slope terms, right? Um, may give you some idea about different sensitivity. Okay, you can tell some stories about it, but at the same time, you may face this kind of question. Well, the slope of GMC versus the slope of Dodge, right? The red versus the blue. How different are they, right? Is that statistically significantly different from each other? Those are slope terms, right? Is that really different from each other? Or in this picture, as long as you can see, right? The range from here down to forever, right? From here going forever, right? They are statistically insignificantly different. They are within confidence bound of each other, right? You see blue band, blue band and red band crossing over here. So and in those areas where this slope is really different, the interval is not that big. So is it worth trying, worth assuming different slope terms? Is a valid question. Okay, is a valid question. The next, the other graph. Can we see it? No, this guy, right? How different are they, right? The slope terms, right? How different are they? And then is it meaningful and useful to distinguish or not? Really, it depends. But that's one approach you can think about. Okay, you can think about. For economists like myself, right, or researchers, we are more used to, okay, finance researchers at least, right? Finance researchers or corporate finance guys, we typically don't assume different slopes for different makers. Instead, what we try is something called fixed effect, company fixed effect. Let's say the we assume, okay, we assume, we assume different intercept. Where is that intercept? Why? For Dodge, and then for whatever company it may be, right? GMC. Let's assume they have some different intercept, Y intercept, okay? And then we call it fixed effect, okay? For certain companies, right? They command a higher price regardless of the years, how many years it has been, right? It was produced. For example, Porsche versus Hyundai. I'm sorry, it's 의선이 형, right? But this is the reality. 정의선 회장님, 정신 차리세요, right? So, Porsche price will always be higher than Hyundai Motor price, right? That kind of company's brand effect, right? We call it fixed effect, kind of a fixed effect, right? It will be there, right? Heterogeneity among firms, right? Will be there. The price sensitivity to years, yeah, but let's assume it to be common, right? Common sensitivity to price. Why do we assume common sensitivity? Well, it depends on the research purpose, but we corporate finance guys, we just don't care about it too much. So that, the sensitivity of price to year, yeah, assume it to be the same. But there may be some company-wise fixed effect or brand equity kind of difference, right? So that's one thing you could try. Later on, I will try some kind of fixed effects model. There you will see many different intercepts. You can also, you can imagine drawing some many parallel lines, parallel regression lines. Okay, simply because of that company specific intercept. Okay, company specific intercept. Okay, so that's that. The next one, yeah. Again, price, the sensitivity of price to mileages. Yeah, it's negative. Let's assume it to be common sensitivity is there, right? And then you can try some fixed effects as well. For example, giving some dummy variable for what is that? The GMC and then Ford, but they, let's say they are parallel. Okay, they don't look like parallel over here because of my finger, but assume it to be parallel. That's the idea. Okay. Okay, so that's something you could try later. Okay. Yes, and then number two question. Number two question. What was that? Yep. Number wait a minute. Yes, it's kind of slow today. I am slow, I know. Yes, number two. Create this CAPM alpha and beta chart for the stocks in Kospi 200 index, like this. And then suggest a pairs trading strategy. Holy cow! I know you must have tried to kill me. You first of all, you need to learn how to do regressions, and then group by group or a whole bunch of y variable regressed on one single explanatory variable. How do we do that regression, right? Must have been very difficult, but the what is it? The implication or the clue or the hint was already there, so you could back solve and then figure out, oh, what to throw in over there and what to throw in over here, right? So let's go. And then here you had like about 25 different stocks, whereas Kospi 200 I gave you 200 stocks. Yeah, must have been troublesome. But you are not alone. Everybody is screwed together. Yes, so no problem. I didn't favor anybody. So that's that. Also, if you have some concerns about, oh, that's too difficult, say it to me. Don't worry. I can slow down to you for you. Okay? Maybe postpone the deadline by 1 week or something. I could try it for homework 2 or 3 or 4, right? As we go down the road. But this week you did not ask for extension of deadline, so we are moving on. Okay. Okay. So we'll try it. Another problem is the relative size of the mark over here, the point, the Google, Apple, all those kind of things. Those was proportional to their market cap, right? But you must have found out something strange. In Korea, if you draw this, and then try to set up the try to set up the size of the point with the market cap, one single company pops up like crazily big, and the others just really tiny small. Why? Because of the dominance of one big guy called Samsung Electronics, right? One single company takes up about 30%, more than 30% of the market cap of Korea, which is crazy, you may say. But this is Korea. Is that the only country that that has kind of this dominant players in their country? That's not. We are not alone. Again, we are not alone. Actually, in Nokia in Finland, right? 20 years ago, they had similar situation. More than like 30 or 40% of their stock market cap went to was by the market cap of Nokia, small country, huge corporation, right? A whale in a small pond, right? Was that kind of situation. You'll see that kind of things every now and then if you work with international data. Get ready for that. Korea is one example. In contrast, in the US, you have many, I call it the pantheon of big corporations, right? There's no one single dominant player. The market is so big, right? 강호의 big guys, right? A lot of them. So you don't see that kind of concentration over here. Anyway, let's try it for Korean stock market. Okay, so going to our R studio. Yes. Number 2, locate all the data in the necessary folders like that, and want to replicate page. And then install packages tidyr, tidyr, and then deploying R, I don't know, dplyr, and I will install that, and make sure you call up this packages by running the library command. And then I'm going to create a data set called kr return. Okay, kr return based on the CSV file that I gave you. Okay, kr return is created. So click and see what the heck is there, right? Okay. Interesting. The date figure is on the left hand side, and then all different companies' ticker symbols are serving as the variable name. Okay, this is actually 40 observation, 40 rows by 201 column matrix, right? 201 variables that you see. First variable date, and second variable this guy, which is Samsung Electronics 005930, right? And then it's in the order of market cap, by the way. So all the way down to 200s, but you can only see 50 columns in the first shot, so you have to punch it. You see the arrow sign over there, right? Double arrows take you to the last columns, right? You can see it right like this. Okay, so that's one thing to notice. Monthly return are shown. Okay, starting from 2015 all the way down to 2020. September is missing value because we don't have we are still before the end of September, but the matrix just threw it in, and then this missing value, so we have to watch out for that. 39th is August 31st. Okay, so we are happy about that. So, and that's that. Summary of this. Yeah, and then it throws me all this thing, right? But what I want to focus on is a date figure, because I want to make sure this is date format in the first place. And voila, it's not character. So we need to switch it into date format using this command, right? As date, right? And then starting with this variable, and then class of date, we just check it again and see this date. Haha, yes, that's good. And then this time, as opposed to previous class discussion, we have dash over here just to match those formats nicely. Okay, you gotta try it this way and that way. So once we figured out this is the way we convert the format of the date, we specify the date and then overwrite this variable. And then so we are already equipped with stock by stock, day by day return data, okay, monthly return data. Then we must import Kospi index return data, which is this guy, right, that you see. And then notice that this is a daily return data. And you see this is COSP 200 data, day by day return data. Okay, day by day return data. And then as we check out the summary, and then we find out that the date is still a character variable over here. So here I'm going to convert it into date format at one shot. Good. And then class like this. Yeah, we check it again. And then another thing I want to highlight is that those variables, right? The COSP 200 is actually in a percentage format instead of decimal format. We want it to be decimal format. Okay, 1 percentage point has to be 0.01, but here it is shown as 1. So we want to divide itself by 100, right? And then overwrite into that variable. Okay, that's this command. Now open it up again, you will see that the number has shrink down by 100th time, right? Yeah, and then another thing not to forget is the stock return data, monthly stock return data. It is also in percentage format. So later on we will have to find out how to divide this guy by 100. Okay, yeah, I'm gonna try some silly way as well as a smarter way of doing it. So go ahead and see it, right? And then the risk-free rate, KRRF, Korea risk-free rate. We import this guy from our the data that I gave you. Yeah, and then another thing to notice is that this guy is a annualized return, and monthly return in a monthly frequency. Okay, monthly frequency, but annualized, which means later you will have to divide it by 12, right? Also, this is in percentage format, so that you'll have to divide it by 100 later. Okay, so summary, yeah, we do it, and then the date is always in this kind of character format, so we convert it. Okay, good. Now what I do over here, KRRF, right, is this guy. Okay, and you see the numbers over here. The risk-free rate, oh my god, in 1988 it was 15.25 percentage point. Oh, wow, imagine yourself, right? Risk-free return is 15%. Whoa, per year, by the way, not per month. So we need to divide this guy by 12, right, to get monthly return. Plus, we need to divide this guy by 100 to make it a decimal format. Okay, so that's what's going on over here. Okay, now checking if there's duplicate observations. So that will, removing those duplicate observations is important. We don't want to do regressions based on duplicate observations. That's why, right? And then it says, it seems like there's no problem doing it because the number of observations did not change. Good. Now, no duplicate. And then what? Well, so I'm going to create a month variable because you've seen before, right? The COSP index return is in daily frequency, whereas the other two data set, risk-free rate and the stock returns, they are in monthly frequency, right? So for COSP index daily return, we want to compound within each month, within each calendar month to get monthly returns, okay? Now, how do we do that? Well, kr ret month, by the way, we need to first set up month variable, okay? Make one month variable, and then for data with monthly frequency, not much of a problem. Just don't get confused, right? The monthly frequency data, originally it was given as of the end of each month, right? Like August 31st or September 30th, like that, right? But we're going to use the first day of each month, right? Don't get hung up onto that day value being 1 instead of 31, okay? We're just focusing on the month value itself. So that's what's going on over here. Yeah, what? Yes. Right. We are separating, okay? We are separating, and then the date value into year and month, and then attaching 0, 1 into that date value. Paste, it says. Paste. 붙여, right? And then Kospi index, it's daily frequency. So we're going to have that each month first day as date value, okay, repeating itself like that you see over here. But no problem, all we need is the month information and year information, so rest assured it's going to be fine, okay. And then risk-free rate, yeah, we're going to create that month variable. Notice that the variable name is common, month, in across 3 different data sets, right? kr-ret, yes, it is created, month variable is created, but where is it? Well, let's go to the final rightmost columns available. You scroll it down, you see month over there, right? Yes, that's that. Now, what? Yes, we need to get monthly compounded return. Remember egg function that you created before in our lecture 1? Yes, so it has to be 1 plus daily return. Here is why we had to convert those percentage figure into decimal format, decimal figure, right? 1% being 1 screws up your process over here, because to compound those returns, okay, we need 1 plus return format, that return in a decimal format, so that 1 percentage point return should be 0.01, right? And then you add 1 to this so that it will be 1.01. That is 1 day's return, okay? 1 plus 1 day's return. Next day you have to compound it by 1 plus that day's return. So cumulatively you're going to multiply. We call it product, okay? Instead of summation, we are going to do it some products like that, okay? And we do that product process within 1 month. So 22 trading days within 1 month, we do 22 products thing. 1 plus R times 1 plus R, 1 plus R. And afterwards, what we do, subtract 1, okay? So that's what's going on over here, egg function, right? We have product function, 1 plus R, and then it says whenever there is a NA, which means like a missing value, NA means nah, not available, right? Not available, and then those missing values, dump it, right? Without this dumping, whatever there is non-missing values, we are going to do the product function. That's what is going on over here, egg function. And then for Kospi 200, right? We need to do that product function by the group called month variable. As long as those month variable is common, then we call it a group. And within that group, we do product function. Okay? Cumulatively, we're going to do it. And then summarize those results. Okay? That will be, by that, we will generate a COSP 200 M data. Okay? M data. Notice this M in the tail. So let's do that. Yeah. Okay. And you see COSP, wait a minute. You see COSP 200M data generated over here. Okay. Now you see monthly the index return. Okay. September, October, November, December. Yeah. Like that. In 2015 all the way down to 2020. Yeah. And you may wonder, yeah, I know, but 2020 September, we did not pass the last day of September. I know there's some, small bit of errors over here, measurement error, we could say, but it's not a big issue in this class. We're gonna just play with the others, right? The excluding September or something, or we may include it, but it's gonna be add to your. It's gonna just add to your noise. The whole purpose of this is to get some sense of how the picture looks like, right? Big picture kind of things. So that's why. Anyway, so notice that the monthly return of Korean stocks is in percentage figure. Yeah. Here we use concatenate. Yes. So here what I'm doing is a brute force or just 단순 무식하게 like the KR return data that you saw each column, right? Those variables, the values has to be divided by 100 each time, and then we have to overwrite into its original variable. Okay, so that's what we can do. Holy crazy, Andy, how did you do that? You see data name and then the variable name and then $sign, and I did divided by 100. You can call me crazy, I know. And then superimpose it. Yeah, this has to be the original variable named, right? So we are overwriting it. But the thing is, 200 times, how did you write all those things? Crazy, Andy. Yeah, I'm crazy. I know. But for this part, there is some easier way of doing it in some commands, right? But when in trouble, okay, just like me, when you are time pressured, right? And you have Excel spreadsheet, what the heck? Just to do it in this way. This is the Excel spreadsheet that I did, like this. I'm a big fan of concatenate function, by the way. I know this is kind of silly, but this is it. So this is, essentially, I need to show you this G over here. Okay, you see concatenate function. Concatenate whatever is in A2, B2, C2, D2, E2, and F2 all the way down. Just treat it as a text and then concatenate. 붙여, right? So attach to each other in this order. A, B, C, D, E, F, right? And I just have to specify what has to go into there, right? The first step is KR red, and the others is a symbol, right? The thing is, I have the list of the stock symbols, right? From that original CSV data. What you have to do is just get that, right? Column, one whole column like this, and then paste it. And then you don't have this one, right? And then specify like this, right? Sign, and then KR red again, which is this guy, and then showing it again, right, over here, and divide it by 100, right? All that I'm trying to do is just to write the command for R over here, and then do what? Well, if you double click this guy, right? You don't need to type up everything, but the Excel types up everything for you. So why don't we just take advantage of it? And then, um, and then, if you go down to 200, right? Get there, copy, and then come back to R, and then paste it, and it will be like this, right? So 200 lines will be there, okay? Of course, this is inefficient, okay? Of course, this is inefficient. So computer science guy will do some more efficient and shorter command. But for us right now, okay, we have the computing power that can compensate for this. So we can just run it, okay? What the heck? This is better than just standing there and do nothing, right? Yeah, like this, right? And you see, if your RAM is big enough, this is gonna be just take a split second to do it, yeah? So KR read that data. Let's open it up, okay? Have some sense of what has happened. You see much more of a 0.0 something, which means, you know, the division of 100 was done. Yeah, fine. If you scroll down, you will realize that Samsung return is missing for most recent month. This is because September is not over yet. Yeah, I told you about this. Also, Samsung is the largest market cap company in Korea. So when it is missing, the rest of the companies would be missing anyway. So that's another way of quickly finding, oh, there must be something wrong. Of course, for this purpose, this kind of approach may be problematic when Samsung stock is halted trading, right? There are some periods like stock splits of Samsung that happened a couple of years ago, right? You cannot use this kind of method when stock split happened and the stock halted, right? Trading halted. But to the extent, you know, of our general purpose, it's okay. Anyway, so let's delete the observations when Samsung's return is missing. So this is what I do, KR return, and filter out whenever 05930 or A005930 is missing, okay? A series of monthly stock return of 200 stocks, okay? The following is not in your homework, okay? I did not ask you to do the homework like the following, but this is just one of my extra steps to demonstrate you about this graphing, okay? So why don't we draw a time series graph of 200 different stocks in one shot, right? Just like the heat graph that you see, heat colored graph that you saw before, right? We did it with US stocks, 500 of them, but why don't we do it with Korean stocks, KOSPI 200, okay? Fine. Set up the grid like this, right? And then set up your graph like this. This is just a copy and paste with just a different designation of the time period and then the variables, right? So here it is. Okay, KOSPI 200. Yes, it shows up like this. Good. Now what? Well, here are several things you can play with. Heat colors, parenthesis 24, it says 24 different color levels, but you can go up to 48 color levels. So if you're sick and tired, but you can try some other levels like this, which will be largely similar, right? But here is another one. You get sick and tired of red and the yellow thing. We can try, instead of heat, some other topology kind of related stuff. And let's see what color it shows. Yeah, blue and green. Yes. So you can switch colors like this. You did it. Yeah, this is one thing you can have fun. All right, um, that's that. If you Google search it, you will be able to find a lot of different coloring options, right? So go ahead and find it. Now, getting back to our original homework, yeah, I have to focus on this. And then here we have to get that market cap data. And actually, yeah, market cap or company names, right? By the market cap or big names. Let's import this thing, right? I just gave this to you like only 2 days before the 1 day before the homework deadline, but it's up to you whether you incorporate it or not. Not a big issue. Just to make your work more fancy, I guess. But so what was the data imported? KR bigs. Okay, KR big names. So bigs look like this. It has those symbol and then market cap, right? You see the market cap huge for Samsung Electronics number one, and then SK Hynix number two. What? Number two is only 1/5 of the biggest guy. Holy cow. It's dwarfed like crazy. This is Korea. And then big names. Okay. Yeah, the names of the companies like this, right? Is shown. Electronics, Samsung Electronics. I told you, okay? At one point, you want to try a translated name of these companies, right? Your Korean names versus English names. How can you translate this thing? Okay, instantaneously. Yeah, why not? We use the Google Translate. The thing is, let's say you go to la 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 la. Okay, Korea company names CSV. Yes, we can see the company names over here, right? In fact, I had already had those English names over here, which I already found. But how do I find it? Okay, translate it easily. Well, copy the column of Korean names and then go to here, translate.google.com, and paste it on the left hand side, and instantaneously you see translated results. Samsung전자, SK Hynix, yeah, all the way down. Just copy, right? Drag down, and then here, why, yeah, and yes, copy, and then come back to your original Excel file. I know it's just taking time. Crazy, I know. Yeah, come back here and then paste it, right? Row by row, it will just paste it. Okay? And some of you may wonder, Samsung Electronics, Samsung 전자 is not Samsung, but how come is it Samsung over here? Where is electronics and corporations kind of things? Well, it's okay for over here, but why did it throw out only Samsung? That has to do with what is accumulated in Google Translation, right? So many people, okay, that suggests to me, right? What I can guess is that so many people in the world, Korean people, have been using Samsung 전자, and it's equivalent to Samsung anyway. Whenever they say Samsung 전자, they say it in English with using Samsung only instead of spelling out the whole Samsung Electronics. They've been spelling out only Samsung, right? So many billions of people were doing that, so much so that the Google Translate is automatically throwing out this one. So that's why. But I would not care too much about it. Okay, just use it, yeah, as long as it is there. Okay, for your quick and easy purpose. Yes, fine. Okay, fine. I'm not going to penalize you for that purpose. Then, where is our RStudio? Yes, over here. Okay, good. So that's Korea big names and Korea excess return we want to generate. Okay, excess return data. What the heck is going on? Because CAPM has to do with your stock's excess return regressed against the market index's excess return. Both excess returns with in excess of what? The risk-free return. So we want to merge your stock return, company stock return, with risk-free returns, right? Monthly database, monthly return frequency, you remember that. So we want to use merge command over here, right? And then once we create KRXR, right, EXR1, right, I created X1, right? So I want to check out the summary of this data, and I want to make sure the format is in the right format that I want. Okay, and you see RF over here attached to the ones that I wanted before, and yeah, RF, yeah, it is there. But months, yeah, we have .x and .y. Why is that the case? Because we had month variable in both KR return and KRRF, and both data is merged. So this duplicate month variable, the computer tried to distinguish by .x and .y. Okay. Now, what shall we do with this? All right, what shall we do with this? Well, I will create kr underbar xr 2 starting from xr1 and then minus dot y, and I say select. Okay, select minus means drop it. Okay, unselect, right? Minus select means drop it. Okay, because we have month.x, which is a duplicate observation. Before we move on further, let me show you kr underbar xr1, exr1. Where are you? Yes, here you are. All right, you see it over here, right? And then let's go to the rightmost columns by scrolling it down there. Month X and month Y. You see those two data merged, right? Based on this, observation number or month by month, right? They are identical, right? Identical months, and we don't need this part, right? This column, so we want to drop that. That's this guy, and once you drop it, I'm going to label it. I'm going to make it a new data set. It's my personal preference, right? I typically hate deleting my data set once, simply because one is created. Okay, the previous data I just accumulated. Why? I had bad experience of deleting all my data that I accumulated over couple of years. Such a miserable experience and traumatic experience that I just don't want to delete it. Okay. Number two, I have huge C drive, the hard drive. So why don't I just accumulate it instead of deleting it? Number three, it makes it easier for me to go back in case I make a mistake, right, of deleting one data, and I can trace back and then see, oh, that is the point that right before I make a mistake. So I can start right from there instead of starting all the way down from the scratch. So that's why I try not to delete it. Okay, it's up to you. I'm not going to penalize you simply because you are not following my way of doing it. Okay, I'm silly, I'm stupid, I know that. So don't worry about it. Okay, and then yeah, rename month.x as month so that we could merge with cosp 200 by month. All right, so krex, yeah, rename, okay, month x into month. All right, and then what? I'm going to merge, okay, kr underbar exr2 and cosp index return, that monthly return data, and then by month variable, as you see. And then from this time, I'm going to overwrite and delete my original data, okay, kr underbar exr. I told you I hate this kind of deletion, overwriting, but just for the heck of it, I'm doing it. Okay, you can also need excess return, right? Excess return, you remember all those stock returns, we need to subtract the risk-free rate, okay? So let's first look at kr underbar exr, okay? The data looks like this. Month variable, yes, and date variable is over here. Don't get troubled simply because these two dates values are different. All we care about is just month. And then we have all different stack, what's that, the ticker symbols, right? 종목 code. And then let's go to the rightmost column, which is this, okay? You see now, not only RF is there, but also cosp index return is there, okay? So now we are ready, okay, to run some regressions. But before that, before running regressions, we are ready to get the excess return. So how do we do that? Well, here's a silly way of doing it that I did, okay? Column by column, just minus, okay, subtract RF, okay? That's what's going on over here. Again, using that concatenate function in Excel. 200 times, crazy. Plus one more time because we need those index return in excess of this risk-free return. So how did I create this silly command using Excel? Here we are, the second sheet, right? Again, I tell you, right, each, right, those ticker symbol, which is column name, and then data set name, and then this is, you know, new in position. And then once I do this, all I do is just use concatenate function, right? Attach everything all together, and then copy all those 200 lines and paste it on your R. Yeah, that's so silly. I know. I'm proud to be silly. Let's do it. Yeah, 600 command lines. Okay. We just do it. Yes. 무식하게. Just do it. Yes. And let's see the computer do. What does it do, right? Of course, you know, you're a better expert than me. You will do some easier command than this, or not easier, but the simpler command or smarter command than this. Okay, so what do we do with this, right? Well, remember, we had to do the CAPM regression for all those 500 different stocks in the US, right? Against the excess return in the market, right? Here we have to do the same, right? 200 different stocks. For that part, we need to create a matrix array, okay? Matrix array. The format is important in that command, right? LS, is that right? LM command, linear model command, right? So that's one thing. And then the other thing is the explanatory variable, right? Explanatory variable has to be in a vector format. But to do that, we need to split our kr underbar exr data into two parts. One is those matrix array of 200 different companies' excess return columns, right? Like that. And the other part is market index return in excess of risk-free rate, right? So we need to separate these into two. So first step of separating is this. I'm going to create kr underbar exr3, which is dropping rf, date, and cost p 200m and month. And then I'm going to create a column matrix called KRMKT, Korea Market, right? There I'm selecting cost P 200M only. So it's going to be a column matrix. The thing is, if we check out the class of these two matrices, it shows like this: data.frame, data.frame. So for some reason that I don't know, okay, that linear model function does not work with this data.frame, that kind of class. It has to be matrix array for dependent variable, and then the vector format for the explanatory variable, right? So how do we create that based on these two? Well, as matrix function over here, and then as vector function over there, right? So we're gonna do this, okay? Let's do it like this and then check it out. Good. So change it, and then it says what? Matrix and array for XR4, and then COSP 200M as numeric, and this is in a vector format. Okay, even though it does class does not show that, it's just a vector with numbers only. So I'm happy about that. Okay. If you check out over here on the right hand side, you will see that COSP 200M is created over here in the lower half over here, okay, which you cannot open because this is not a matrix or data frame. This is because simply a vector, okay, array of numbers. Now time to do regressions, CAPM regressions. So CAPM, linear model LM, parentheses, and tilde. All these things, you run it, and it generates the KR on the bar, CAPM, like this. You can see the description of this. Holy cow, a lot of them, right? A lot of information is over here. What we need is the alpha and beta coefficient estimates, right? That you see over here, okay? So let's see. We're going to create a matrix called KR on the bar AB, because alpha and beta, AB, right? And this is going to be coefficient of this, the things, right? And some, all the rows, but in the column wise 2 to 1, right? Is that right? Row and column. So we're going to do that, okay? And it shows like this, right? All those company names, and then not the names, but the matrix, the stock ticker, right? And then alpha and beta, okay? Showing over here, right? Like this. Intercept. So the beta and alpha in different columns. So plot alpha and beta. Yeah. So here is what I'm gonna do. Plot, right? Plot those KRAB, and then beta and alpha. Alpha will be on the y, and the beta will be on your horizontal axis. And then so draw some lines, and then label should come from row names of KRAB, which is KRAB. We can open up the matrix like this, and then you see the row names is not a serial name of 1, 2, 3, 4, 5. It is just a what is that? The ticker symbol. You can switch it into you can merge this thing into with the company names data so that you can work it out. But here, yeah, um, right. Uh, Here I will just use the ticker symbol as it is, and then the number in CEX and KR bigs over there. It shows that it is the market cap of those stock, right? KR big underbar bigs, right? That's this guy, right? That's this guy. So market cap is over here. So let's use this guy as a determinant of the size of each ticker symbol. Samsung Electronics, the biggest one, shows up like this. Crazy. I know. But that's the reality. The remaining guys are showing up like dots, dust. Right. Yeah, the color navy. Right. Row names. You can actually, maybe you can actually label this guy as column bigs the let's try it this way, and then one because we know bigs right over here. Oh, it is again the symbol, right? Sorry about that. Names. Yeah, yeah, yeah. So the second one, big names. Yeah, names. The second one. How does it show? If we try it, does it work? Yes, Korean. All right. Yes. Big sense of achievement. So I can do another thing. 1, 2, 3. Column 3 instead of column 2. I can say column 3. And yes. Oh, it's just overwriting that. So I'm going to, yeah, I'm playing with it. So like this, right? Another thing I want to highlight is I divided the market cap with 5, what is it? 50 million or something? Yeah, 50 million. Right, 50 million, 5천만. Because of the unit issue there, right? I just wanted to do it that way. Another way you can try is take the log of that market cap, maybe. Let's try it. Log, can we? Of this guy. Okay. Let's do it because I said log is a nice uniform transformation and that pushes down the biggest extreme so that it makes reasonably a bell curve kind of more clustered way so that the size difference will look smaller compared to this one. So let's see. Taking log may take some time for the computer. Do we see any difference? Okay, it's blinking. Did it change by any chance? I don't know. Yeah, but anyway, likewise, you can try some various ways to show it in different ways, right? Okay. Samsung Electronics is too big. Can we just see without it? then you can delete that guy like this. Plot alpha and beta. Okay. Well, this time, instead of using the market cap itself, we can introduce the inverse rank number of Kospi 200 stocks, where Samsung Electronics, the biggest one, will have 200, and the second biggest one will have 199, the third 198, and then all the way down to 1, right? The smallest one will have 1. And then, so the size of these dots will be like 1 all the way up to 200 differences, right? Instead of that huge difference. So for that purpose, how do we do it? Well, I'm going to import KR-BIGS data, okay, from our, and then plot alpha and beta using this. I would say, like this. So BIGS 2, those 200, okay, that will determine the size of these guys. Yeah, I divided into 200 just to make it as a standard, right? So the smallest one will be 1 over 200 size. Of course, we want the Samsung name in it, or company name in it. Alpha and beta, just like this. KR-BIGS 3. Yeah. Over here. So it will look like this. Hopefully. No, the error, right? KRAB2, they cannot find it. You're in trouble. Big names 3. Yeah. Where did I put it? No, I should have done it differently. Big names 3. Come on, Andy. You should be better. Yes. Like this. Yep. Like this. Right. Now you see this, right? All different colors. If you don't like it this way, I can delete it and then replace it like this. And size will be a bit bigger. Okay? Yeah, right, all these things, right, may show up like this. Okay, so that's how we do it.